This is the video for 1.7, the distributive property. The distributive property lets you multiply a sum by multiplying each addend separately and then by adding the products together. And remember what an addend is. An addend is a number which is added to another number. And so this is a very fancy way of saying A times B plus C is the same thing as AB plus AC. So what am I doing? I'm taking the A and I'm distributing it or multiplying it to each term. A term is a single number or variable or numbers and variables multiplied together. It's very important for you to understand a term is separated through addition and subtraction. So in 4x plus 7, 4x is my first term and 7 is my second term. They're separated through addition and subtraction. A constant is a term that has no variable. So in the example 4x plus 7, 7 is my constant term. The value of that term will not change no matter what the value of the variable is. And a coefficient. A coefficient is a numerical quantity placed before and multiplied with a variable. So in the example 4x plus 7, 4 is my coefficient. It's the numerical quantity that's attached to the variable through multiplication. And like terms have the same variable factors. So 3x squared y and 2x squared y are like terms because they both have the variable factors of x squared y. Let's go to example number 1. 3 times x plus 8 is the same thing as saying 3x plus 24. Well, why? Because what I'm doing is I'm taking this 3 and I'm distributing it into each term through multiplication. So 3 times x is 3x and 3 times 8 is 24. And think about what this is saying. This is saying I have 3 x plus 8s. So if I have 3 x plus 8s, what do I have? I've got 3 x's and then I have 24. Another way to do it would be to think of it this way and just add it down. This is not practical, I'm just showing you why that works. Okay, here, because of the commutative property, it doesn't matter whether it's written this way or if you want, you can rewrite it and put it like this. It doesn't matter. But what we're doing is we're taking the negative 4 times a positive 5b, which is negative 35b, and then we're taking a negative 7 times a negative 4, which is a positive 28. And I encourage you, at least for now, to go ahead and draw your circle and draw your lines as you distribute so you don't lose track of what you're doing. Okay, go ahead and hit pause and work out the on your owns. Here are my answers. The first one is 5x plus 35. The next one is 36 minus 2x because this reduces. The next one is 1.2 plus 3.3c. And finally, the last one is negative 2y squared plus y. Because what's happening here? I'm taking a negative y and I'm multiplying it by 2y. That's like saying this. Negative y times 2y. Oops. Which is the same thing as saying negative 1y times 2y, which is what? Negative 2y squared. Because negative 1 times positive 2 is negative 2, and y times y is going to be y squared. And then I take a negative y and I multiply it by negative 1, and so I get positive y. If you have any questions on that, let me know. Okay, let's go to example number 2, rewriting fractions. This is the same thing as saying this. That's just a concept that you need to memorize. And the reason why it's important to do that is because if either one of these terms could reduce, you have to reduce them. So knowing that concept, what I want you to do is I want you to do all these on your own problems and break up the terms and reduce any terms if you can. Okay, go ahead and look at my answers and compare them with yours. Notice, for example, here, once I broke it up, I can reduce this, and that becomes 1/2. Here, I can reduce both of these, and that becomes 5/4 plus 1/2. So that's why you break it up, is because you want to see if there's any term that can be reduced. Okay, next example, using the multiplicative property of -1. All this is saying is, if I have a negative times 2y minus 3x, this is the same thing as saying -1. That's the same thing as saying -1 times 2y minus 3x. And so what I'm doing is I'm distributing out the -1. When you have this situation, you're not just changing the signs. What you're doing is multiplying each term by -1. And when you do that here, you get this, -2y plus 3x. Okay, so go ahead and do these on your own, and remember what you're doing is you're distributing out a -1. Here are your answers. Go ahead and pause the video and just take a look at them and make sure they match yours. Combining like terms. 8x squared plus 2x squared is the same thing as saying 10x squared. If you have like terms, if you have terms that have the same combination of variables, you can combine them. Otherwise, you cannot. You can only combine them if they have the same combination of variables. So let's talk about why. This is extremely important that you understand what's happening here. If I have 8x squared plus 2x squared, what I'm saying is I have 8 x squares. I don't know what x squared is, but I know I have 8 of them. Then I'm adding 2 more. So then how many do I have in total? I have 10. I have 10x squared. Well, let's proof this. Let's see how this works. Let's just pretend x is 3. If x is 3, this becomes 9. I have 8 9s here, plus I have another 2 9s. So that means I have a total of 10 9s, which is 90. Well, let's just follow through with the proofing and make sure this is all correct. Okay, well, I said x is 3, so that means okay, and let's go back to my beginning here. I said x is 3, right? And there's your proof. And I know it seems kind of silly for me to go through this, But it's extremely important that you understand why when you're combining like terms. When you're combining like terms, you add the coefficients, but then keep the same combination of variables. And this is why, this is what's happening here. And I encourage you to rewind that and watch that again until you fully understand what's going on there. So let's go to the next example, combining like terms. These can get very, very long. So I encourage you to circle out the terms as you go that you're combining and then cross them out when you're done so you don't lose your place. And let me show you what I mean, because again, these can get very, very long. Okay, so I have a 5x. What can I combine it with? I'm taking a 5x and I'm combining it with a negative 3x. And this is why in algebra they say, you know, there's really no such thing as subtraction. What you're doing is adding negatives, because fundamentally what I'm doing is I'm taking a positive 5x and I'm combining it with a negative 3x. That's what I'm doing here. And so then I have 2x. So let's cross that off so I don't lose my place. Now I have a negative 3 and I can combine that with a positive 4. What happens when I take a negative 3 and I combine it with positive 4? I have 1. And then finally I'll cross that off so I don't lose my place, and then finally I have a 6y, which I can't combine with any 1. Poor guy. And so appropriate form, just to let you know, is you put it in ABC order with your constant last, although don't worry so much about that right now. Okay, so go ahead and work out the on your owns. And here are your answers. Notice what I did was I actually put the 1 in there so I don't lose track of that. If ever there's nothing there, it's a 1. So this is actually 3y minus 1y, which is 2y. And here, I did the same thing here. I put the 1 in. Otherwise, you're going to miss it. If there's nothing there, it's a 1. And go ahead, the coefficient's 1. And so go ahead and write it in so you don't miss it. And then notice here, I actually did the keep, change, change. Go keep, change, change. Go ahead and go through that process so you don't mess up. Okay, go ahead and do your homework and let me know if you have any questions.